Phase 1. Nebula. The first phase of stellar evolution is the nebula phase. A nebula is an interstellar cloud consisting of dust and many elements such as hydrogen and helium. Despite their low temperature, nebulae are very luminous because of their size. Once a nebula gets large enough, it collapses under its own gravity. As it collapses, particles begin to smash together and create heat, otherwise known as a protostar. Phase 2. Main sequence. The main sequence is where the star will spend most of its lifetime before fusion. Fusion is the act of combining small atomic nuclei to create larger nuclei. Many people believe our sun, a main sequence star, is burning. This is wrong. It's actually fusing nuclei together, creating enormous amounts of energy. Once a star stops expanding, it becomes a red giant. A red giant may be colder than its original state, but it is still luminous because of its size. At this point, the small and big stars start to go through different phases. Once a small star runs out of hydrogen to fuse, it starts to fuse helium and helium together to create carbon. The star starts to expand and have its temperature decrease. Once a star stops expanding, it becomes a red giant. A red giant may be colder than its original state, but it is still luminous because of its size. In roughly 5 billion years, our sun will enter the red giant phase. A planetary nebula is when a red giant starts to eject its outer layer and collapse into a white dwarf. Ultraviolet radiation from the white dwarf ionizes the expanding gas, causing it to glow. The nebula disappears once the white dwarf can no longer ionize it. Once the nebula disappears, the star will approach its final stage, the white dwarf stage. A white dwarf is the last stage in the evolution of small stars. The white dwarf is basically the core of a star in a very dense state. A white dwarf is so dense, a teaspoon of its matter would weigh over 5 tons. A large star goes through the same process as a small star, except instead of a red giant, it becomes a red supergiant. Red supergiants are one of the most largest stars in the universe. As you can see, the sun is a few pixels wide compared to the VV Cephei A red supergiant. Once a red supergiant is at its final days, it explodes into a supernova. A supernova occurs at the end of a large star's lifetime, when its nuclear fuel is depleted and cannot be supported by the release of nuclear energy. After the supernova, two things could be formed, either a black hole or a neutron star. The formation of these depend on the amount of matter left from the supernova. Neutron stars are very dense, spin very fast, and usually have a radius of 10 to 15 kilometers, or 69 miles. Because neutron stars form from burnout stars, they don't glow. The collapse of the stars caused the matter to be converted into mostly neutrons, hence the name neutron star. A black hole is basically mass from a dead giant star squeezed into a single point. The point at the center of the black hole is called a singularity. Within a certain distance of the singularity, the gravitational pull is so strong and so dense that nothing, not even light, could escape. That distance from the singularity is called the event horizon. The event horizon is not a line drawn around the hole, but a point of no return for anything that crosses it. The more mass the singularity has, the larger the event horizon. Surprisingly, a black hole has the same mass as the star it used to be, just more compressed.
Nobody wanna see us together.